In today's lesson, we're going to be talking about similar polygons. Similar polygons are the same shape, but not necessarily the same size. Corresponding angles are congruent, and corresponding sides are proportional. So, symbolically, if we wanted to show that these two figures were similar, we would say that figure ABCD is similar to figure EFGH. So that would mean that side AB is proportional to side EF, BC is proportional to FG, CD proportional to GH, and DA proportional to HE. We would also be able to say that the corresponding angles are equal. Angle A is equal to angle E. Angle B is equal to angle F. Angle C is equal to angle G. And angle D is equal to angle H. And we're going to see how this works in this next figure. Let's say that you are just given the statement. You don't even know what these figures look like. That JKLMN is similar to RSTUV. Name the corresponding angles and sides. Okay, let's start with the angles. Those are the easy part. Angle J and angle R are both in the first positions, so those are corresponding angles. K and S are both in the second position, so those are corresponding angles. L and T are in the third positions, so they're corresponding angles. Angle M and angle U correspond. They're in the fourth positions, so we'll list that pair, and then lastly that leaves us angle N and angle V, which are in the last positions, and those would be corresponding angles. Now the sides. Let's think about the sides. JK are next to each other in the first and second positions, so they make a side. R and S are in the same position in the second figure, so we'll say JK and RS. KL and ST. They are in the same corresponding positions in the similarity statement. LM and TU. And I should put the bars over the top. MN and UV. And lastly, we do have to connect this. Remember, so the very last one is going to go back to the first. So we're going to have NJ. And with the last going back to the first and the second statement, VR. If you want to make a sketch, that's fine, but you don't have to. You can actually tell what the corresponding angles and sides are just by looking at the similarity statement. So let's go on to the next page. We want to know, are these quadrilaterals similar? And they're similar if the corresponding sides have the same scale factor. Okay, so this is what we're looking for. Corresponding sides, or I should say lengths of corresponding sides, have the same scale factor. Okay, so let's see if they do. We can tell that in the first figure, the side with length 15 corresponds to the side with length 10, so 15 over 10. What does that reduce to? 3 over 2. Okay, so now let's see if the other corresponding sides have the same scale factor. We see the side that has length 6 corresponds to the one with length 4. 6 over 4. Well, if we reduce that, we get 3 over 2, so looks like the scale factor is 3 over 2 on both of them. It's looking good so far. Now the side with length 9 corresponds to the one with length 6, so 9 to 6. That also reduces to 3 over 2. And now let's look at the last pair of sides. Corresponding sides, 12 over 8. That also reduces to 3 over 2. So it looks like we've got the same scale factor on every pair of corresponding sides. So we're going to say yes, they are similar. Okay, now let's take a look at this problem. You have a 3.5 inch by 5 inch photo that you are enlarging. You're going to make it into a poster, and the poster needs to be 16 inches wide. How long will the poster be? So let's start. See if we can draw a picture of this. We have a 3.5 by 5 photo. So here's your photo. And you need to make a poster, which is going to be bigger. And obviously this isn't to scale, but here's our poster. And the poster needs to be 16 inches wide. So here's your width. And we need to know how long it's going to be. So we're looking for x here for the length. Now, the thing is, the photo and the poster, in order for the picture to not be distorted, they're going to have to be similar. So they're going to have to be proportional to one another. So let's see how we can set this up. The 3.5 inch width in the photo corresponds to the 16 inch width in the poster. Okay, now the lengths will have to have the same scale factor as the corresponding widths. So we can set them equal to each other. So the length of the photo needs to correspond to the length of the poster. The scale factors, again, have to be the same. That's why we can set these equal to each other. So now we're ready to cross multiply. So when we do that, we have 3.5x equals, and we're going to have to take 16.5 times 5. Oh, I'm sorry, I shouldn't have had a 0.5 here. Just a moment. There, that's better. I'm sorry, I copied down the wrong number. That should have been a 16 because the poster is 16 inches wide. So let's go back and fix that. So we've done that. So we have 3.5 times x equals 16 times 5, which gives you 80. Now we want to get x alone, so we're going to divide everything by 3.5. The 3.5s will cancel, and you get 80 divided by 3.5 gives you 22 point, let's round it to the nearest tenth in this case, 22.9 inches. So the length of the poster is 22.9 inches. Moving on. We have JKLM, one figure, is similar to figure PQRS. Find the value of x. And so we can look at this picture, and we see that in the bigger figure, x corresponds to 10 in the bigger figure. So we can write that as a ratio of 10 over x. That should be equal to the ratio of, well, the other two numbers that we know it looks like are 15 and 6, and those do correspond to each other in this figure as long as they're similar. So because KL and QR are both in the second and third positions, and those sides do correspond. So we have 15 over 6. So what we're going to do now is try to solve this. So let's cross multiply. So we have 10 times 6 is 60. 60 is equal to 15x. We want to divide everything we can by 15. The 15's cancel, and we have the x is equal to 4. So that's it for today. Thank you very much for joining me. Do bring all of your questions to class so we can further our discussion. Thank you very much.